Get ready for an epic tale that spans millennia and crosses paths with some of the most legendary figures of all time. It all begins with the mysterious text known as Surya SIDDHANTA, which has scholars of centuries. Legends has it that the amazing text on astronomy was written by none other but Mayasura. He was the father-in-law of Ravan from epic Ramayana. It is said that Mayasura's knowledge came from none other but the sun god himself, Lord Surya. According to legends, he received direct teachings from the deity and gained vast knowledge of world's astronomy and astrology among other things. This source was then compiled into Surya Siddhanta, which is named in honor of its divine source. According to recent research on the location of celestial bodies, it has been proposed that the Surya Siddhanta was possibly composed around 1200 BCE, but the story doesn't end here. Astronomers and scientists have been attempting to accurately predict the length of solar year, the time it takes for the Earth to complete one orbit around the Sun. It was in modern science that we finally came up with the figure of 365.25 days. But wait, what if I told you that the ancient Indian astronomical text Surya Siddhanta predicted the length of solar year with incredible accuracy over thousands of years ago? Yes, you heard that right. The sages who wrote this text calculated the length of solar year to be 365.2563627 days, which is only off by 20 seconds from the modern scientific calculation, and that 20 seconds is still debatable. But what even more remarkable is that many of the predictions made in this million-year-old text have been validated by modern science. For instance, the text accurately describes the rotation and orbit of the Earth as well as the position and the movement of planets in the solar system. But perhaps the most impressive prediction made in the stunning book is its calculation of speed of light. The text describes how light travels at a speed of 2202 yojanas in half of nimisha, where nimisha is the unit of time. This calculation is remarkably close to the modern scientific estimate of speed of light, which is approximately 29 crore 97 lakh 92,458 meters per second. It is very complex to do calculation behind the fact specified in Surya Siddhanta, but let me try to show you the calculation surrounding the speed of light. As per Surya Siddhanta, light travels at a rate of 2200 yojanas in half of nimisha. A yojana is an ancient Indian unit of length that is equivalent to about 9 miles, and nimisha is the unit of time that is equivalent to about 16 by 75th second. To convert speed of light described in Surya Siddhant into modern units, we first need to convert yojanas into meters. 1 yojana is equals to 9 miles, which is equals to 14,484 meters. Therefore, 2,200 yojanas is equals to 3 crore 18 lakhs 85,568 meters. So, 1 nimisha is equals to 16 by 75th second. Therefore, half of nimisha is equals to 8 by 75th second. Using these conversions, we can calculate the speed of light described in Surya Siddhanta as follows. Speed of light is equals to distance travelled by time taken. Therefore, 3 crore 18 lakh 85,568 meters divided by 8 by 75th second, which is equals to 29 crore 97 lakh 92,453 meters per second. The scientific estimate of speed of light is equals to 29 crore 97 lakh 92,458 meters per second. This is remarkably close to the modern scientific estimate of speed of light. Surya SIDDHANTA also surprised us with the prediction of length of lunar month. According to the text, lunar month is determined by the time it takes for moon to complete one orbit around the earth, which is approximately 27.32166 days. This calculation is incredibly close to the modern scientific measurement, which put the average length of lunar month at 27.32156 days. Its calculation of lunar month is only off by about 0.6 seconds compared to modern measurement. Imagine without the aid of any technology, these ancient astronomers were able to determine size of our planet to within such a small margin of no error. The text suggests that there may be a connection between celestial events and human behavior, particularly through the practice of astrology. While this idea has not been scientifically validated, it continues to be a topic of interest and debate among astronomers. Now, coming to one among the many mathematics mentioned in the text, generally, trigonometry is believed to be first developed by the ancient Greeks, but there was a place far away from watchful eyes of world where something extraordinary was happening. In the 14th century, in the town of Sangamgrama, a young man named Madhava founded Kerala School of Astronomy and Mathematics. He was a brilliant mind, and soon his school became well known for trigonometry. The Kerala school made significant contribution to the development of trigonometry, included the invention of trigonometric functions such as sine, cosine, cosecant, tan, etc. But was it possible for a small town in India to make such a significant contribution to the world of mathematics? It is believed that the root of their knowledge came from the ancient Indian astronomical text Surya SIDDHANTA. Legends tell of a time when this text was written long before the Greeks had even heard of trigonometry. Surya SIDDHANTA contains a wealth of information on trigonometry, including tables of values for different angles. Their contribution was particularly important in the field of calculus, which was later developed by the mathematicians such as Isaac Newton and Leibniz. If legends are true with regards to the origin of Surya Siddhant, it predates Greek contribution to trigonometry, including that Greek astronomer Hipparchus, who was considered to be the father of trigonometry. This is not all, but the legacy of Surya Siddhanta goes on and on. This is written in such a way that to completely understand it, you need to be expert in astronomy.